A recipe uses 2 cups of sugar for every 3 cups of flour. You want to make double the recipe. How much sugar and flour do you need now? Or, what if you only want to make half? This is exactly what equivalent ratios solve. And once you understand them, scaling anything, recipes, maps, models, mixtures, becomes completely straightforward. Welcome back to the Ratios, Rates and Proportions series. In this second lesson, we will talk about equivalent ratios. Equivalent ratios are ratios that represent the same relationship, even though the numbers look different. Think about fractions. 1/2 and 2/4 look different, but they mean the same thing. Ratios work exactly the same way. The ratio 2:3 and the ratio 4:6 are equivalent. They represent the same relationship. For every 2 parts of one thing, there are 3 parts of another. The numbers are bigger, but the relationship is identical. Creating equivalent ratios is straightforward. Multiply or divide both parts of the ratio by the same number. Start with 2:3. Multiply both by 2, you get 4:6. Equivalent. Multiply both by 3, you get 6:9. Equivalent. Multiply both by 5, you get 10:15. Equivalent. The key rule: whatever you do to one side, you must do to the other. This is exactly the same principle as equivalent fractions. Let's go back to our opening recipe. Sugar to flour ratio is 2:3. Question 1. Double the recipe. Multiply both by 2. 2 times 2 equals 4. 3 times 2 equals 6. New ratio, 4:6. You need 4 cups of sugar and 6 cups of flour. Question 2. Make 5 times the recipe. Multiply both by 5. 2 times 5 equals 10. 3 times 5 equals 15. New ratio, 10:15. You need 10 cups of sugar and 15 cups of flour. Same relationship. Different quantities. Always equivalent. Now, here's the type of question that appears most on grade 7 and 8 exams. The ratio, 3:5 is equivalent to 12 to what number? Step 1. Ask yourself, what was done to 3 to get 12? 3 multiplied by 4 equals 12. Step 2. Do the same to 5. 5 multiplied by 4 equals 20. Answer, 3:5 is equivalent to 12/20. Let's check. Simplify 12/20 by dividing both by 4. That gives 3:5. Correct. Equivalent ratios also work in reverse, dividing down, not just multiplying up. For example, the ratio 36:48. Write this in its simplest equivalent form. Step 1. Find the highest common factor of 36 and 48. The highest common factor is 12. Step 2. Divide both by 12. 36 divided by 12 equals 3. 48 divided by 12 equals 4. Simplest form, 3:4. 36 to 48 and 3 to 4 are equivalent ratios. One is just a scaled-up version of the other. One of the most useful tools for working with equivalent ratios is a ratio table. A ratio table shows multiple equivalent ratios organized in columns, making it easy to scale up or down quickly. Let's build one for the ratio 3:4. Multiply by 1, 3:4. Multiply by 2, 6:8. Multiply by 3, 9:12. Multiply by 4, 12:16. Multiply by 5, 15:20. Every row is equivalent to 3:4. Ratio tables are extremely useful for solving word problems quickly because you can scan across and find the value you need without calculating from scratch each time. Let's apply this to a real-life situation, map reading. A map has a scale of 1 centimeter to 50 kilometers. Question 1. A road on the map measures 3 centimeters. How long is it in real life? The ratio is 1 to 50. Multiply both by 3. 1 times 3 equals 3. And 50 times 3 equals 150. The road is 150 kilometers long in real life. Question 2. A distance in real life is 350 kilometers. How many centimeters is that on the map? First think, what was done to 50 to get 350? Multiply by 7. So, 1 multiplied by 7 equals 7 centimeters. The distance on the map is 7 centimeters. Here is the most common mistake with equivalent ratios. A student is told the ratio of red to blue is 3 to 7 and needs to find an equivalent ratio where red equals 15. The student writes 15:7, keeping blue the same and only changing red. That is wrong. If red goes from 3 to 15, that's multiplied by 5. Blue must also be multiplied by 5. 7 times 5 equals 35. The correct equivalent ratio is 15:35. Never change one side without changing the other. Both sides must be multiplied or divided by the same number always. Now it's your turn. Pause the video and solve these. Question 1. Find two equivalent ratios for 4 to 7. Question 2. The ratio 5 to 8 is equivalent to 25 to what number? Question 3. A car travels 60 kilometers on 4 liters of fuel. Using equivalent ratios, how far does it travel on 10 liters? Pause now. Here are your answers. Answer 1. Multiply 4:7 by 2 to get 8:14. Multiply by 3 to get 12:21. Any correct multiplication is valid. Answer 2. 5 multiplied by 5 equals 25. So, 8 multiplied by 5 equals 40. Answer, 25:40. Answer 3. Ratio is 60 to 4, simplified to 15 to 1. Multiply both by 10, and you get 150:10. The car travels 150 kilometers on 10 liters. Here is your final challenge. A school has students and teachers in the ratio 24 to 1. If the school has 18 teachers, how many students are there? And what is the total number of people in the school? Pause and solve both parts. Let's solve it. The ratio is 24 to 1. Teachers are 1 part and equals 18. So, 1 part equals 18. Students are 24 parts, 24 multiplied by 18 equals 432 students. Now we have total numbers of students and teachers. So, total people will be 432 students plus 18 teachers equals 450 people. The key step, when one part equals a known value, multiply every other part by that same value. This works for any equivalent ratio problem. So, today you learned what equivalent ratios are and why they work. How to create equivalent ratios by multiplying or dividing both parts equally. How to find missing values in equivalent ratio pairs. How to use ratio tables to organize and scale ratios quickly. And how to apply equivalent ratios to real-life situations like recipes, maps, and fuel consumption. In the next lesson, we move into unit rates, how to find the cost per item, speed per hour, and rate per unit. These are the ratio skills you use every single day, without realizing it. Subscribe, so you wouldn't miss it. And don't forget to follow us on Facebook, Instagram, and TikTok. See you in the next lesson.